Hello, I'm Bose. Welcome to my channel, Learningbuildslife, and today we're going to talk about this numerical on equivalent resistance. So let's begin. Three resistors of resistances 2 ohms, 3 ohms, and 6 ohms are connected in circuit to yield an equivalent resistance of 4 ohms. How are the resistors connected? Okay, now we can begin. Now here we need to take different possibilities of how the resistors can be connected. The one connection that may result in 4 ohms of equivalent resistance will give us our answer. So we need to keep on trying. Like our first possibility which we can take is when all the resistors are in series. At that moment, then to get the equivalent resistance, we have to just add up all the resistances. Like here we have 2, 3, and 6. 2 plus 3 plus 6 equal to 11, which is unequal to 4. Hence our conclusion is no. We can't take this connection because it's unequal to 4. Okay, moving on to our next possibility. 2 are in series, and the series of 2 is in parallel connection with the third. Okay, in this possibility, we can take 2 of them, 2 of the resistors connected in series as one total thing with parallel to another resistor. Now the values we can vary, like hence we have taken the same thing for the other 2 possibilities because the values may vary. Like in this circuit, let's take 2 and 6, the 2 and 6 ohms, that one, as in series, and the third one to be of 3 ohms. Then let's see what happens. Now, since this is in series, let's calculate that one's equivalent resistance, that's 2 plus 6 equal to 8. We get this as the equivalent resistance of this in series. Now, using this total value, we can calculate the equivalent resistance to this third one, that is of 3 ohms that we have considered in this possibility. We took 8, and now, if you can recall, in one of our previous episodes, we have talked about a special relationship to get equivalent resistance in case of parallel connection. That is 8 into 3, that is R1, R2, by R1 plus R2. 8 into 3 by 8 plus 3, equal to 24 by 11, that in any case cannot be equal to 4, hence unequal to 4 again. And hence again, our answer is no. You can't use this. Okay, next the same thing, hence we put a do sign. It's the same thing, so let's take the series one is 3 and 6. We have to work with different possibilities. 3 plus 6 is 9. So this is our equivalent resistance of the series part. Now, since we have taken 3 and 6, the other one should be 2. And again, we're using the same formula. 9 to 2 by 9 plus 2 equal to 18 by 11, which in any case cannot be equal to 4 again. Again, unequal to 4, so our answer is no, it won't work. Last possibility in this kind of connection. Our last possibility in this kind of connection is taking 2 and 3 ohms as the series one, and the third one to take as 6 ohms. Then let's experiment what happens. 2 plus 3 is 5. We got that one as 5. Now let's do with the 6 as the third one in parallel. Then we get 5 into 6 by 5 plus 6. Then we get 30 by 11, which again is unequal to 4. And again, our answer is no. So now we have to move on to our next set of possibilities. Here are the other possibilities. Okay, number 5. 2 are in parallel connection, and the parallel set is in series with the third. In this, we have any 2 of the resistors in parallel, and then we add up the other resistance to get, because it's in series, with that parallel set. So let's calculate, and here in 6 and 7, we have the same possibilities, but the values of the resistor may vary according to the situation. In our first possibility, let's take 2 and 6 are in the parallel set. Then let's get their equivalent resistance.
I will cut.
If we take 2 and 6 are in parallel, then we get the equivalent resistance as 2 into 6 by 2 plus 6 equal to 12 by 8. We get 12 by 8 as our equivalent resistance of this parallel set. Plus, we have taken 2 and 6, so the other one is 3. Plus 3 is never going to be equal to 4. So this cannot be our possibility, and we put a no, a big no. Okay, next possibility we can take is 3 and 6. If we take 3 and 6 in parallel, then let's see what we get. Then if we do that, then 3 into 6 by 3 plus 6 equal to 18 by 9 equal to 2. We got that equivalent resistance, and since we took 3 and 6, we're also having 2. That makes 2 plus 2. 2 plus 2 equals 4. And this is our ideal. This is our ideal connection, and we put a big yes over here. But still, we have 2 more possibilities left to check. So even if we got all 3 our answer, still let's check out the other possibilities. Okay, in our next one, we are taking 2 and 3. Let's take 2 and 3 in the parallel connection. If we do that, then we get 2 into 3, but 2 plus 3 equal to 6 by 5. Now I've got the equivalent resistance, and now that we have taken 2 and 3, we have 6 left. That makes 6 by 5 plus 6 can never, ever be equal to 4. That means this is also a big no. Seems like we're not going to get any more possibilities. And finally, all 3 are in parallel is our last possibility to think of. In this, I can guarantee that whatever you take, it's going to be less than 2, 3, and 6 because the special relationship that we talked about when we talked about the properties of equivalent resistance when the resistors are connected in parallel and all were in fractions. And you know fractions means obviously less than 4, so it's going to yield less than 4, even less than 2, 3, and 6. It's going to be less. It means less than 2, 3, and 6. Everything is going to yield less than 2, 3, and 6. That means this also is a big no. It cannot be possible. That means our option is 6. Number 6 possibility is our ideal connection for the resistors to get 4 ohms of equivalent resistance in a connection of resistors with resistances 2 ohms, 3 ohms, and 6 ohms. And now I'm giving you a few moments to look at the board so that you can clear your concept. Hope you enjoyed solving this numerical with me, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.